Welcome back to Cinderella Math. Today I'm going to be doing a study guide for a Calc 2 private tutoring student of mine. The answers are already going to be in there, but I'm just going to go over it. This is mostly on like advanced integration, pretty much, and advanced integration techniques. There are a couple improper integrals as well. So feel free to pull up a chair. And again, this is for Calc 2 and it's kind of some random integration problems. Alrighty, here we go. I'm going to zoom tight here. And again, I'm covering up the answers. This is also just one of those, probably like a Pearson textbook website type of thing. I can white this all out. And this is our first problem. We are going to integrate by parts. And our formula for that is the integral of u dv is uv minus the integral of v du. Now, on this particular problem, they did tell us what to use for u. They said let u be x. So that makes the derivative of u 1 with respect to x. Do you need to write the 1? No, not really. And they said let dv be e to the 4x dx. So let's integrate that to go backward to v. Well, the integral of e is himself, but because of chain rule, we need the derivative of the power. So we need 4 dx. So we just put the 4 and then we do the reciprocal to kind of unput it, which would be a quarter. So now v would be a quarter and then itself. All right, and now that's kind of what I call the side work. Let's go into the actual formula. So we need uv, so uv minus integral v du, which is really just dx, because again, the 1 can go away. All right, so we had du is 1 dx or just dx, and v was 1. Okay. And now let's work this out. This can clean up. This would just look better if you just put the x here. 1/4 x e to the 4x minus this constant can come outside the integral. You don't have to do that. I think it'll just make your life easier. And now to integrate e to the x, it is itself, except we need the derivative of this power because of chain rule. So we'll put a 4 to make it look right. And then we'll do the reciprocal, so another quarter on the outside. And then this is fine. A quarter times a quarter is a 16th, and the integration of e is itself. And don't forget your plus c for that constant. And there we are. Integration by parts. And again, they were nice enough to tell us the u and the dv. And they're going to be nice enough to tell us again on number 2. Same topic, integration by parts, and they do go ahead and tell us what to use for u and dv. So that's very nice. Again, this formula is the integration of u dv is uv minus integration of v du. They have told us to use u is x, so there's our u, and there's our dv. So dv. So derivative of u would be 1 dx or just dx, and then integrate to go backward to v. But because of chain rule, we need derivative of this, which is 6. Undo that with the reciprocal. So 1/6 integration of cosine. So you're asking yourself whose derivative is cosine? It's sine, and you keep the argument, basically the parentheses. Okay, and now we go into the formula. So uv minus integration of v du, which again, you don't really need the 1. All right, clean that up. This would just look better right there. So 1/6 x sine of 6x minus, let's pull this constant. And now let's integrate sine of 6x dx. But again, because of chain rule, we need the derivative of the argument, which would just be 6, and we undo that with the reciprocal, so another sixth. So we are left with 1/6 x sine of 6x minus 1/36 because they multiply. And the integration of sine, so whose derivative is sine? That would be negative cos. Keep the argument plus c. And now just clean that up one more step here because this is negative times negative. That would turn positive 1/36 cos of 6x plus c. Okay, and there we are. And I think we are done integrating by parts. Now we're going to integrate some trig. So your trig needs to be strong here, or you need to have a handy dandy like trig cheat sheet with you. We are integrating from 0 to pi over 2 of cos to the 7th sine to the 5th. And there's probably two ways you can go with this one. I'm going to turn everything into cosine, but you probably could have also turned everything into sine. So you just need to remember from trig, this is called a Pythagorean identity, that cosine of an angle squared plus sine of that angle squared is 1. So if I want to turn everything to cosine, let me solve this for sine. So move that over. So we are given that sine squared is 1 minus cos squared. Okay, that's just going to be our trig knowledge that we need. So we are going to keep the cosine to the 7th, and we're going to turn sine 5 into sine to the 4th and a sine by itself. Okay, but look up at our little trig notes. We need sine squared. Okay, well, that's fine. Can't we just say sine to the 4th is sine squared squared? Okay, yeah, because 2 times 2 is 4. Okay, but then I wanted it all to go to cosine. So I still have cosine to the 7th of x. And then using this rule right here, sine squared is 1 minus cosine square. So this will be 1 minus cosine square x squared. And then we still have this. So it is all cosine except that one singular sine. That's what you want. You want that one hanging off the end. Why? Because we are going to let u be cosine. And the derivative of cosine is negative sine. So we have regular sine, so just negate, negate. Okay? So we now have negative integral of u to the 7th, 1 minus u squared squared du. That is where we're at. And I'm going to erase a little bit now, so if you need to pause me, feel free. Okay, we are going to go ahead and square that out. So we're going to have negative integral u to the 7th, 1 minus u squared times itself, because that's what squaring means, right? Times itself. 1 times 1 is 1. This would be negative u squared, positive u to the 4th. So we now have u to the 7th, 1 minus negative 1 makes negative 2u squared. Okay, and then go ahead and distribute that u 7th. So we have negative integral of u to the 7th minus 2u to the 9th plus u to the 11th du. And you'll notice I haven't been writing the 0 in the pi over 2 because that applies to x, not to u. All right, integrate. So we have negative u to the 8th over 8th minus 2u to the 10 over 10 plus u to the 12 over 12. 2/10 is a fifth, so I'm going to cancel that and make that a 5, 1/5, okay? And then I'm going to go ahead and distribute the negative. So that's negative u to the 8th over 8, positive u to the 10th over 5, and negative u to the 12th over 12. And now we need to know what we're integrating from. So again, it's not these anymore because those were the x bounds of integration. Let's see what the u bounds of integration are. And I could have done this a long time ago. I just didn't. Okay, I'm going to erase a little bit, so pause me if you need to. Let's see what our bounds are. So our substitution was u is cos x. So this right here is an x number. Plug that in. So u is cos of 0. Cosine of 0 is 1. So u is 1. So our bottom bound is now 1. Boop. And now let's do our top bound. So again, this is an x, but we said u is cos x. So plug that in. So u is cos of pi over 2. Cos of pi over 2 is 0, so our top bound is 0. Now, I know that feels weird to have the bounds. Usually it's the greater one on top. It's fine. That's just how it came out here. All right, again, I'm going to have to cover some stuff up. This is such a long problem. Okay. All right, you always start with the number on top. So let's plug in 0. That'd be negative 0 to the 8th over 8 plus, there is no negative 0, right? 0 to the 10th over 5 minus 0 to the 12th over 12. This is all just going to be 0. And then it's always a minus. And now plug in 1. So that would be negative 1 to the 8th over 8 plus 1 to the 10th over 5 minus 1 to the 12th over 12. You can go ahead and distribute this negative, which will turn positive 8th, because that's just going to be 1. Negative 5th, because again, that'll be 1. Negative, negative, so that'd be positive 12th, because again, that'll be 1. If you're allowed a fraction calculator, by all means, use a fraction calculator at this point. If you're not, and you have to crank everything by hand, 5 and 12, the common denominator would be 60, but 8 doesn't go into 60. I think you got to go all the way to 120. So let's turn everything into 120 if you're doing this by hand. So this would go 10. This would go 24. And this would go 15. So 15 plus 10, that's 25. 25 minus 24 is 1 over 120. And that is answered. Now, did you have to do all that fraction? Maybe not. If you're using a fraction calculator, don't. But there you go. That is the answer. If you're straight up allowed Desmos, go to Desmos. Integration from 0 to pi pi over 2. Cos of 7, cos to the power of 7 of x, sine to the 5th of x, and then put that all in a big parenthesis, dx. And why did it not work? Ah. Oh, okay. They don't like how I typed it. So cos of x to the 7th sine of x to the 5th. And fraction. There we go. But most likely you're not allowed just to jump right there and you need to show work, but it's nice to check. All right. We're going to number 4, which is another trig integral. This one's easier though, in my opinion. Let me find my work on this one. So we're still integrating from 0 to pi over 2, but this is a lot, I mean, I wouldn't say a lot less complicated, but certainly less complicated. All right, you do have to have some trig knowledge here. We have to know the power reduction rule. Power reduction. Cos square of an angle is the same as 1/2 parenthesis 1 plus cos of double the angle. That is just a rule. Have that written down somewhere. And by the way, if it's sine squared, it's the exact same thing, but a minus in the parenthesis. Let me write that neater. There. So we just need the cosine one for today here. This is what we need. Okay, so let's pull this 5 out. So that's going to be 5 integral. And now we're using the power reducing formula for this cos squared. So we're changing that to 1/2 parenthesis 1 plus cos 2 theta and still d theta. Let's pull this half. So that's going to be 5 times a half, better known as 5 halves, integrate 1 plus cos 2 theta d theta. And I like to split this integral. That's totally allowed. Just put a d theta right there. It just seems easier to me. 5 halves will drop the integral of 1. So that's got technically, like, it's really 1 theta to the 0. So bump that one up. So that would be 1 theta to the first over 1. And that's kind of silly to write, right? We take off all those ones, and it really is theta. Plus, let's integrate the cosine part, but remember we need the derivative of this part, the argument. So this needs a 2, so put a half. Okay, now what's the integral of cosine? It would be sine, and keep the argument. And then we are going from 0 to pi over 2. Okay, always do the top one first, so wherever you see theta, put in pi over 2. So this will be 5 halves pi over 2 plus a half sine of 2 times pi over 2. All that, and then minus, put in the second one. So that'll be 0 plus a half sine of 2 times 0. Okay, let's just work this out. So that's 5 halves pi over 2 plus half sine, these 2's will cross cancel, and this will just be pi, minus, this will be 0 plus a half sine 0, but sine of 0 is 0. Half of 0 is 0. This is all just 0. So that's nothing there. So we get 5 halves pi over 2 plus, what is sine pi? Go back to unit circle, pi's right here, which is left 1, up nothing, CS. Sine pi is 0. So this is gone and gone. And there we go. Multiply right across would be 5 pi. Right across the bottom would be 4. Answer. So once you had that power reduction formula, it went pretty nicely. And that's it. Coming to number 5. This one is a mess. Okay, right here, evaluate the integral. This is going to use a trig substitution. I won't say 100% of the time, but a lot of the time when you see a plus in this situation, you're going to do a tan substitution. And you're going to take the square root of this number. So that would be 4. So we're going to let t, sometimes x, doesn't matter, but this time t, whatever that square root was, so 4, and then tan theta. Okay, so now take the derivative of that. You just should know the derivative of tan is secant squared. So this would be 4 secant squared d theta. And then go ahead and solve that top one out for tan. So divide by 4, divide by 4. So t over 4 is tan. We won't need that till the end, but it's kind of good to have. Okay, now let's substitute. You will not need to write the 0 and 4 right now because that is in the t world. We're moving to the theta world. So we have integration, no bounds at this moment, dt, which is 4 secant squared d theta, square root 16 plus t squared. Well, our t is 4 tan theta, and then we're going to square. Okay, so the top is fine. If you don't like the d theta on the top, you can stick it to the side. And the bottom is going to be 16 plus 4 squared is 16. Tan squared is tan squared. Okay. And then you can notice on the bottom that they have a common factor of 16. So we're going to pull that out, which will leave 1 plus tan squared. Okay, we need a little trig knowledge at this point. I'm coming up at the top in green. Trig knowledge is a Pythagorean rule. 1 plus tan squared is secant squared. You should just know that or have a trig cheat sheet handy with trig identities on it. So this is now. Top is still fine. Root would be 16 secant squared. Okay, but what is the root of 16 is 4, and the root of secant squared would just be secant. Okay, 4's would cancel. This one would go and just leave this one. So we have integration of secant theta d theta. Now, hopefully you either know what the integration of secant is or you're allowed to use an integral cheat sheet. The integration of secant is natural log absolute value secant theta plus tangent theta. Okay, and then we need to go from something to something, but again, it's not from 0 to 4 because those were our t bounds. We need our theta bounds. Okay, so again, that's kind of had a lot of knowledge you kind of just had to know, or hopefully you can use like a resource to find it. Okay, so we need what is secant theta and what is tan theta? Well, we have tan theta up there, but we don't have secant theta. So I'm going to have to white out. Let's make a triangle. Right triangle, put your theta, and we, right here, over in the dark navy blue box, tan theta is t over 4. So ka toa, tan is toa, so opposite is t, and adjacent is 4. Okay, so again, that came from tan of theta being t over 4. Let's go ahead and get the hypotenuse. Using Pythagorean theorem, that would be t squared plus 4 squared, so 16 is hypotenuse squared. Take the root, take the root. So our hypotenuse is root t squared plus 16. So we need tan theta, we've got it. We also need secant theta. Well, secant's the flip of cos. So if we get cos, which is ka, then we'll just flip it to get secant. So ka adjacent is 4 and hypotenuse is root t squared plus 16. So just flip that one. Okay, so we have natural log absolute value secant, which we just got, is root t squared plus 16 over 4 plus tangent, which is t over 4. And now we can go from 0 to 4 because we put it back into t. Okay, again, I'm going to have to white out. All right, always starting with the top one. So everywhere we see t, I'm giving it a 4. So this would be natural log, absolute value. 4 squared is 16. 16 plus 16 is 32. So that'd be root 32 over 4 plus 4 over 4 is 1 minus natural log. And now everywhere you see t, give it a 0. So that'd be natural log. 0 squared is 0. So that would be just square root 16 over 4 plus 0 over 4 is 0. Okay, so natural log 32, you could break down to be 16 and 2. Square root of 16 is 4. So this would be 4 root 2 over 4 plus 1 minus natural log. Square root of 16 is 4. So this one is just natural log of 1, which is 0. That's just a rule we should know. And these 4's cancel, and we get natural log of root 2 plus 1. And then this would just be, who cares about minus 0? That is your answer. Natural log of root 2 plus 1. You can drop the absolute value because that's positive, and natural log can only be positive. So that one's a mess. You had to have a lot of background knowledge, had to do a lot of the tinkering with the trig. I mean, it works, but it's a mess. Feel free to watch that one a couple times. Okay. Ugh, this one's also no fun. Okay, let me find my work. All right, let's take this one over to Desmos. We are finding the volume of a solid rotated about the x-axis, and it's going to be enclosed by the following curves. X equals 0, y equals 0, x equals 6, and y equals 36 over x squared plus 36. So we are basically taking this area right here that I'm squiggling in black, and it's rotating that way. So this is the disk method that we'll be using here. All right, I'm going to just go right there. So we are integrating, and we do pi. That's just the formula for disk method. And we are going on the x from 0 to 6, because those were our bounds. And then how tall is this? How tall is this rectangle? Well, that's going up to the function, and so is this one, and so is this one. And we do that, that's called the radius, because you're going to rotate it, right? So it's going to come down here. And you do that squared. So then we're going to take our function, which was 36 over x squared plus 36, and then you're going to square that with respect to x. Okay, we can go ahead and square the 36. That's fine. So that is 1296. And then squaring the bottom, we'll just leave it as x squared plus 36 squared. Then let's go ahead and take that constant out. So we have 1296 pi 1 over x squared plus 36 squared. That just looks prettier if you kind of remove the constant there. And it's just going to make life better. And again, this looks pretty similar to the last one. We have a plus in the bottom with a square and something that can be rooted. So we're going to do the tan substitution again. Take the square root right there, so that'd be 6 and then tan x. Last time it was t, this time it's x, same difference. So derivative would be 6 secant square. And then go ahead and solve for tan from this one. If you divide by 6, x over 6 is tan. Oh, wait. Theta. 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 There we go. Okay, let's make some substitutions. And we will not put 0 to 6 anymore because that's the x bounds. So it's fine. 1296 pi integration. So this was still 0 to 6, but we're not anymore. 1 over 6 tan theta squared plus 36, all that squared, 6 secant square theta d theta. This should have a d theta. Oh, my pen might be starting to die. Okay. Woo! Okay. Let's square out the bottom. Well, not completely, but this part. So we're going to have 1296 pi integration 1 over 6 squared is 36. This would be tan squared. And then you still have plus 36, and then that's all still being squared. And then we still have 6 secant squared d theta. You can see down here we have a common term of 36. We're going to pull that out, so we still have 1296 pi integration. I'm going to just put this on the top. 6 secant square d theta over pulling the factor of 36, and then that would be tan squared plus 1, still square. Okay. Trig rule. We used this on the previous problem, maybe not the previous problem, but a previous problem. That is secant squared. That's a Pythagorean rule that tan square plus 1 is secant square. So we're going to have 1296 pi 6 secant squared and then 36 secant squared squared. Because this square still lives, okay? All right, well, we can square the 36. I'm running out of colors. Okay, So 1296 pi. The top is fine. 6 secant squared d theta. 36 squared is 1296. Secant square square is secant to the fourth. Okay? We can pull out this fraction. That's just a number. Pull it out. So we're going to have 1296 pi times 6 over 1296. Cancel, cancel. So that's 6 pi on the outside. And then on the inside, secant square, secant 4. Well, subtract, that will leave us 2 on the bottom. So that'd be 1 over secant squared. All right, I'm going to have to delete. We're down there in a yellow. Pause me if you need to. Okay, I'm going to come up to the top in blue. So we have 6 pi integral. What's the reciprocal of secant? Flip that up, that's cos squared. Okay. Now use the power reducing formula from a few questions ago. Cos squared is 1/2 1 plus cos of 2 theta. That's just a rule. Pull the half. 6 times a half would be 3 pi. And then I split this into 1 d theta plus cos 2 theta, d theta. This needs a 2 because of chain rule, right? We need the derivative of that, so put a half. Oh, my pen's dying. I'm so sorry. Okay, 3 pi. Integration of 1. So really it's 1 theta 0. Add 1. So that would be theta 1 over 1, but we don't write the 1s. Plus, oh, no, half. And integration of cosine. Whose derivative is cosine? Sine. Keep the argument. There's our integral, and this should be like that. 3 pi times all that. Okay. But now, do we need to evaluate? Yes, we need to evaluate from 0 to 6, but that was in X world, right? We need it in normal world. So, let me just check my notes here. Let's turn our X's into thetas. So we could have done this from the get-go, and maybe we should have. It's fine. So the original was integrating from 0 to 6, blah, 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 dx. Okay? So let's plug 0 in for x. That's an x. So 0 over 6 is tan theta. My pen is going. 0 equals tan theta. Where on the unit circle is tan 0? At 0, right? Right here, the point is 1, 0. But tan is the y value divide the x. So 0 divide 1 is 0. So theta is 0. So when x is 0, theta is 0. So our bottom bound is still going to be 0. And now let's put in 6. Right there. So 6 over 6, better known as 1, is tan theta. Where is tan theta 1? It's the middle one in quadrant 1 at pi over 4. Because that point is root 2 over 2, root 2 over 2. I'm sorry, my pen is just losing its mojo. I will pause after this problem and let the pen rest for a second. So if you did y divide x, that's root 2 over 2 divide itself. So that is 1. So the theta, what is that radian, is pi over 4. So that's going to be our upper bound. Okay, so now we're ready to evaluate. Okay, plug in pi over 4. So that's still 3 pi. This pen is just, it's done. Pi over 4 plus 1/2 sine. This is twice pi over 4, right? So it'd be 2 pi over 4. 2 pi over 4 reduces to pi over 2. Okay, and then you would minus plug in 0, but this would be 0, and sine of 2 times 0, so that would be 2 times 0, which is 0. Sine of 0 is 0, so this whole second one is gone. It's just 0. Okay, so now we're at 3 pi. And then sine of pi over 2. Well, pi over 2 is right here. What's that y value? 1. So that would be pi over 4 plus 1/2 times 1. And then who cares about timesing by 1, right? That's just going to go away. Because 1 times 1/2 is 1/2. Answer. Okay. That is the volume of our thing rotated, revolved around the x-axis. If you wanted to distribute, you could. That would be 3 pi squared. Oh my gosh, this pen. Over 4 plus 3 pi over 2. And if you wanted to get a common denominator, you could. But my students' program took the purple answer. So I don't know if you really need to continue on. Okay? All right, I will have to come back with a part 2 after the pen has like 2 minutes to rejuvenate itself. Sorry about that. And I will be back with the part 2 of this study guide. See you soon.